Hi there, I hope you all are doing fine. As you know, we have started introduction to Econometrics for finance course in second semester, and we have seen, of course, the first chapter and also the second chapter. In the first chapter, in chapter 1, the introduction chapter, we have defined econometrics. We have seen the difference between economic and econometrics model. We have seen the methodologies or the methodology of econometrics, and we have seen also the goals of econometrics before classes closed due to the COVID-19 pandemic. So today I will show you examples based on chapter 2 and chapter 3 lecture notes by hoping that you have read the lecture notes of this chapter. Of course, chapter 2 and chapter 3 are interrelated. Chapter 2 is the base for chapter 3. The main difference is that chapter 2 is a case of simple regression, that is, the relationship between two variables only related in linear forms, whereas chapter 3 is the case when we have more than two or more. So let us see first the examples on chapter 2. You can read these sentences. It says we have two variables, one independent variable, that is test score, and our dependent variable score in final exam. The assumption is that when home take exercise increases, when we provide exercise for students, home take exercise, their score in final exam increases and the relationship is positive. So to check whether this relation is statistically significant or not, we have to collect data, we have to analyze the data and interpret and check whether the relation is significant or not. So based on the given information, the following estimable model is formulated, that is, y is the functions of our final exam is the functions of test score. So our interest is to find the value of the sample parameter beta 1 and check whether this parameter, the sample parameter, is significant or not. So the second equation is estimate. So the first is estimate the relationship between score in final exam and average score in the two exercises, whether the relationship between these two variables is significant or not. So this is first, this is the population equation. From the population equation, since it's difficult to collect but conduct sample, we have to take sample and we have to estimate the sample parameter. This parameter beta 1 hat is the sample parameter. From the sample parameter, we can infer about, we can analyze about the population once we get the value of the sample parameter. So based on the information, we have the value of the dependent variable y, we have the value of x, then we can calculate y squared, we can calculate x squared, we can get the product of the two, y times x. Again, we can get a small y. Small y is the deviation of the value of y from the mean. This is the mean one. The total value of the sum of all the y value is 440 divided by our sample size 10. Okay, the mean is 44. So when we subtract the deviation of each value from the mean is this one. Similarly, in case of, this is the case of course, the case of y. Similarly, the case of, this is the case of x. Here also you can get the deviation of each values of y from the mean. Once we get this information, the next step is substituting the formula that we have in the PowerPoint lecture note. Then we can get beta 1 hat, the parameter, the sample parameter. And we can get also the intercept parameter. Once we get these values, we can formulate the estimated equations. Now our interest is to interpret this coefficient 3.333, but it is positive, of course, but at this time we can't know whether this coefficient is significant or not. So to check the significance, we have to conduct test of significance or test of hypothesis tests. Of course, for test of hypothesis, we have to have a standard deviation. To get the standard deviation, we have to calculate the variance of each value, because standard error is the square root of the variance, as you can see each in the table. For the sake of time, let me here is the standard deviation of the sample parameter beta 1 hat. The second question says compute R square. Of course, R square means the proportion of the variation in the dependent variable that is explained by the variation in the explanatory variable or the independent variable. In our case, in this case, we have only one independent variable. How much the variation in this one independent variables vary our dependent variable, the final exam score. Of course, R square is equal to explained sum of square over total sum of square. The summation of explained sum of square plus residual sum of square. When we say residual, it is unexplained, is equal to total sum of square. So R square is equal to 0.333. That means it implies that the two homework exercises were significantly determinants of students' achievement. Almost 73.3% of the total variation in final exam score is due to the variation in home tech exercise. The remaining 23.7% is maybe due to other variables that we didn't incorporate in this model. It may be other students' talent, other factors that we didn't incorporate. The third question is test the significance of the slope parameter at 5% level of confidence interval. In social science, out of 100, 5% error up to 5 and 1% error is tolerable. Confidence interval is 95% confidence interval or 5% confidence. So our null hypothesis is that beta 1 is not different from 0. Beta 1 is not significant. Against alternative hypothesis, no, beta 1 is different from 0. Beta 1 is significant. So to test this, there are of course different types of tests: the confidence interval test, the standard deviation test, the t-test. From this, let us use the t-test. According to the t-test, it is t-calculated is equal to beta 1 hat minus beta over the standard error of beta 1 hat. In this case, this beta 1 is the population parameter. In this, it is given 0. So if this is 0, beta 1 hat over standard deviation of beta 1, 3.33 over 0.7, we get 4.4. Then we can compare t calculated from t critical. T critical is the value that we get from the t table. Using the t table, you can read using the confidence interval, the 5% confidence interval, and using the degree of freedom in this n minus k. The degree of freedom is n minus k, where n is number of observation, k is number of independent variables. In this case, we have only one independent variables, and also, of course, the interceptor. So we will have to, our number of observation is 10. 10 minus 2, it becomes 8. At 8%, 8, the degree of freedom is 8. Degree of freedom means the number of independent values which can be assigned to a statistical distribution. So based on this, since our null hypothesis is different from 0, it can be negative, it can be positive, so we have a two-tail t-test. If we have two-tail t-test, we have to divide 5% into 2, it becomes 2.5%. So we can read this 0.025 at 8 degree of freedom, we get the t critical 2.30.6. Then compare this t calculated with t critical. Since t calculated is 4.6, which is greater than the t critical, we conclude from this that beta 1 is statistically significant. That means the independent variable, the number of exercises, significantly affects students' final exam score. I think it's clear. Let us also see one example on multiple regression, chapter 2. Hopefully you have read this chapter. Consider this information. The information given here is the case of multiple regression when there is two independent variables that affect our dependent variable y. Informations are given. Based on this information, the first question essay is find the estimates of the slope coefficients. Find beta 1 and beta 2. B, compute the variance of beta 2 hat. What is the variation of beta 2 hat? The sample mean from the population mean. Test the significance of beta 2 hat, the slope parameter, whether this B2. Before interpreting this coefficient, we have checked whether it is significant or not by using the significance test. By the way, there is no difference between significance test in case of multiple and single regression. In case of multiple regression, of course, we have to undertake or conduct two tests of significance. The first is the significance test of each parameter, that is beta 1, beta 2, beta 3, blah blah. And we have to conduct also the overall significance of the model. We call it the F test. Of course, there is also some differences in R square. In case of single regression, we use only R square, but in case of multiple regression, we have to report in our regression result adjusted R square. Adjusted because in case of multiple regression, when we increase the number of independent variables, the value of R square may increase. That means increase by adding more variables, even if the added variable have no relationship with our dependent variables. That means when we increase our other independent variables in our model, whether that variable is relevant or not, it increases R square. So to solve such problems, an alternative measurement of goodness of fit or coefficient of determination is adjusted R square. Usually it is reported in case of multiple regression analysis. So interpret this question decides, interpret or compute R square and adjust R square. And the last question tests the overall significance of the model. To test overall significance of the model, as I said, we have to use the F test, overall significance. we have to use f-test. I think the first is calculating the slope parameter for beta 1, beta 2. We have already this formula in our PPT lecture note. So it is a matter of substitution. Already the information is given, the raw data, the raw information is given, so we can substitute and we can get the value of beta 1, and we can get also the value of beta 2. Once we get the values, again the value of the intercept term alpha, then we can write the estimated equation and we can interpret the coefficients. Of course, as we said, before interpreting the coefficients, we have to check whether the coefficient is significant or not. Can be tested using student t-test. The significance, as it is similar with the simple regression, t calculated is equal to here is beta 1 hat or standard error of beta 1. We get this one. Compare this value with the t critical. So since in this case, look, compare the two, the t calculated and the t critical. The t calculated is less than the t critical. So reject the alternative hypothesis that says beta is different from 0 and accepts the null. That means the coefficient is not significant. It is not different from 0. The conclusion is beta 1 is statistically what? Insignificant. It does not affect our interest or our dependent variables. Again, R square, I think the formula is the same. The difference is in case of adjusted R square, we have to adjust R square by dividing by the number of variables minus, number of sample size minus number of variables. We get this one. There is a difference in between adjusted and the R square. The last concept is test the overall significance of the model by using what we call the f-test. It is the test of the overall significance, the f-test. You can calculate the f-test by using the formula. Then you can compare f calculated with f critical, like the t test. The decision is based on this. If the f calculated is greater than the f critical, the decision rule is to reject the null and accept alternate. We can say that since the f calculated is greater than the f critical, we conclude that the model is significant. That is, the dependent variable is at least linearly related with one of the explanatory variables. So it significantly affects, at least one of the variables significantly affects our dependent variable y. I hope these examples are helpful to understand the lecture notes on chapter 2 and chapter 3. Thank you. If you have questions, any difficulties, you can communicate me through phone anytime. See you. Bye.